13, indexing. Now this is the last lesson as part of the finance course. Indexing has been a personal favourite of mine. I just always feel that there will be an ATAR question one day on indexing because it's such a key feature. It's such an important concept to go through in terms of finance because it's making withdrawals out of an investment account, but you're taking into account inflation. So inflation is where how money is sort of losing its value, and therefore you need to draw more of it out to basically receiving the same amount of money. And so like a typical, if you've heard of a consumer price index, you may have heard that it might be like 3% or 2%, and therefore you need to draw a little bit more out so you're getting the equivalent amount of money. So that's essentially what indexing is. You're indexing your payments. So inflation reduces the value of money. Indexing counteracts this so that the amount can stay the same, or maybe you want to increase it a little bit more, but that's fine. Payments are indexed when they increase in line with inflation. So that might be something like CPI, which is the consumer price index. So we've got this little rule here. Now this rule here is really handy. It's a recursive sequence that you can use to help you find a balance after a certain period of time. And what it does is it actually starts increasing your withdrawals as well. Okay, so what's indexing? You're increasing the value or your withdrawals over time, okay, in line with your consumer price index / inflation. Okay, now this chunk here, this is the withdrawal chunk. This is the bit where it takes into account the indexing. Specifically, this bit here, the INF stands for inflation rate. This is the part that's increasing your payment over time. Okay, so we're going to have a look at this example and we're going to use this indexing rule. You may know that whenever you see indexing, there's no finance app here. Okay, so we're going to be using our recursive rule instead. So let's have a look at this example. Fernando wishes to deposit $200K into an account that will earn interest of 8% per annum, compounded annually. He withdraws $25,000 at the end of the first year. Now this is where the indexing comes in. At the end of the second year, he's going to withdraw $25,500. At the end of the third year, he's going to draw $26,010, and so on, with the annual withdrawal being increased at 2%. From each year to each year. So you can see here that it goes from 25K to 25.5K to 26.01K, and you can see it's increasing by 2%. And you can double check that if you so wish. If I put this in, 25K times by 1.02, it should equal 25.5K. If I times that by 1.02 again, it should equal 26.01K, etc. Okay, now this rule, that highlighted chunk, is the part that helps you increase that amount. Calculate the amount in the account after the first and second withdrawal. Now, what we're going to do for this is we're just going to do it manually, then we're going to use the rule. So, how do we work out A1? Well, A1 is you have $200,000. Now, what's going to happen to that amount? You're going to increase it by the interest rate, which is 8% per annum, so it's going to increase by 8%. Then we take out the first withdrawal. Now the first withdrawal at the end of the first year, they're going to take out $25,000. Now if I put this into my calculator, I get my amount of $191,000. Now we move on to A2. Now A2, we get that A1 balance, we times by 1.08, and what are we drawing out at the end of the second year? We're drawing out more money. We're drawing out $25,500 to keep in line with indexing and inflation. A2 is going to now be $180,000, $180,780. There we go. Now, we're going to make this into a sequence because they might be asking for a value down the track. So let's use this rule. AN plus 1 is equal to 1 plus R on N, AN minus your payments times by 1 plus your inflation rate all to the n. Okay, so let's chuck it all in. Oh, and you've also got your old A0. So 1, and I'll change colour here just so there's a lot we've just written down. 1 plus, now R in this case is the annual interest rate, 8%, and it's on 1. Now, because of this, I'm just going to clean this up and just make it 1.08, but you can use 1 plus 0.08 on 1 if you so wish, times by AN minus your original payment. Okay, so what was your original payment? And I'll put this here. Your original payment is $25,000. Then we times it by the inflation rate, 1 plus 0.03. Now we can see that this is going to change to 2%, sorry. And then we put it to the power of n. Next we put in our A0. The initial amount was $200,000. Okay? So what we now have is our recursive rule. We can go into a finance app now and we can now model this. The question says, determine the balance of the account immediately after the 5th withdrawal. So let's go into here, menu, sequence, clear all, and let's put this rule in. Now this bit here, to the power of, and there's your n button there, okay? That's really important to put to the power of n. $200,000. Now that to the power of n is the thing that's going to increase it. So after 1 year, the n is 1, it increases it by 2%. After f n's 2, it increases it by 1.02 times 1.02, so increases it by 2% twice. So we can see that effect kicking in here. Okay, now our next step is we're going to plot. Always select the sequence. There we go. Now we're going to scroll down, and I think we're meant to find A6 as I remember. Oh, it's A5. Okay, and there's our amount, 141,679.25. There we go. So this is the amount after the 5th withdrawal. And then the last question is, determine how long the account lasts for and determine the final withdrawal. Okay, so we'll go back to our app. When will it last? So we've got this. A11, it's $12,884. And then A12, it's dipped below, it's gone to negative $17,000. Now obviously, realistically, that will go to 0, and that's the amount you've overpaid by. So let's go back. Let's write those values down. Okay, so we've got those values there. So therefore, it will last for 12 years. Okay. Now it's also saying determine the final withdrawal. Now this isn't so straightforward. I think I can show you 2 strategies for this, and it's not so straightforward. This is the best strat, and I want to show you the best strat for final payment. And it's the strat that we normally don't like. Okay, it's the one I don't recommend doing. Remember, you had your underpay, and then you times by the interest. So we know that the final payment is going to be A11, which is 12,884.18, and then we're going to earn the 8% interest. Okay, now that is going to be your final withdrawal. Okay, now that is definitely the best method, and I'll show you the other method, but you know, this is definitely the best method for this. So that's your final payment. Easy, right? Now, if you want the other strategy, like what we normally do, other strat, what we do is we know that A12, they've overpaid by $17,169.44. The problem is that, well, what amount did they withdraw from the account? Remember, it was 25 grand, but they're increasing by 2% every year. Now, to work out how much they draw out at the end of the 12th year, you use this equation here. 25 grand And then how many times do they increase that by 2%? They increase it, at the end of 1 year, it's 25 grand. But then in the second year, it's times by 1.02. At the end of the third year, you times it by twice, 3 times, 4 times, 5 times. Now, for 12 years, it stands to reason it will be 11 times. So it's to the power of 11. So if I put that amount in, the amount I tried to withdraw from my account was $31,084.36. So now we can use our strategy. And in fact, I'll just for my working, I'll take off that $17,169.44. That's how much you've overpaid. And therefore that final amount is 13,914.9, and in this case I think it was 2. So you can see here they're very, very similar. Now this one here is definitely the strategy to use, but I hope you sort of appreciated how this other strategy is working as well. Let's move on to E. E is not so straightforward. Determine how much, and the how much interest was earned during the first 2 years. Okay. So how much interest was earned during the first 2 years? I'd probably do something like this. How much interest was earned in the first year? So you could just make a table, right? So we started off with $200,000, and it went to we get 0.08% of that. Okay, so let's calculate that. 200 times 0.08. So we get 16,000. I think I might have put one extra 0 in that. We get $16,000 of interest in that first year. Okay, then so it's going up by that, but then they're drawing out 25k. Okay, so we're going to go 200 plus. Oh, actually, we can use the balance, right? It's going to be 191. We've already worked that out. Okay, so this is A0. At the end of the year, they've earned this, and A1 is going to be $191,000. Okay, now we're going to work out the interest earned in that second year at $191,000, and we get 0.08. So 191 times 0.08, and we get a total of $15280, and then we can sum these together. So we can see it's $31,280 of interest earned. Okay. So there's one strategy there that you could use to help you figure out that problem. They're sort of more manual, these ones, and they're not so straightforward. Thank you. I hope this video was useful. In the next video, we'll be looking at the indexing your term. Thank you.